Let's look at trig values of special angles. For example, let's find the exact value of sine of 2 pi divided by 3. Now the sine of theta is equal to the y coordinate of the point of intersection of the terminal side of the angle and the unit circle. So we need to find the point where the terminal side of this angle here, 2 pi divided by 3, intersects the unit circle. That is, we need to find this point here. Now, since 2 pi over 3 is in quadrant 2, its reference angle here is pi minus 2 pi over 3, which is equal to pi over 3, or 60 degrees. So we can form this triangle shown here. It's a 30, 60, 90 triangle with hypotenuse equal to 1. Remember, the radius of the unit circle is 1. Therefore, the side adjacent to the 60-degree angle has length 1/2, and the side opposite the 60-degree angle will have length square root of 3 over 2. And let's recall why this is true. So let's draw an equilateral triangle here with side lengths equal to 1. Now the angles here are 60 degrees. And then we can split this equilateral triangle into two congruent 30, 60, 90 triangles by dropping this perpendicular bisector here. That is, we can form these two triangles here. If the total measure of this top angle here was 60 degrees, then each of these is 30 degrees. This is still 60. This is still 60. This still has length 1. This still has length 1. But then this bottom side has been split into two pieces of equal length. So this has to be 1/2, and this has to be 1/2. So the question is, what is the length here, z, of that side of each of those triangles? Well, let's look at this right triangle here. By the Pythagorean theorem, we have that z squared plus 1/2 squared is equal to the hypotenuse squared. Or z squared is equal to 1 minus 1/2 squared, which is a fourth, or z squared is equal to 3/4, which means that z is equal to plus or minus the square root of 3 over 4, which is plus or minus the square root of 3 divided by 2. But z here is the length of a side of this triangle, and so we're going to choose the positive value here. So this z then is square root of 3 over 2. That is, this right triangle here is the triangle we see here. So this distance is square root of 3 over 2, and this distance is 1/2. Now remember that xy is in quadrant 2, which means the x-coordinate has to be negative. So this point then is negative 1/2, and the y-coordinate is positive, so the y-coordinate is square root of 3 over 2. And therefore, like we said earlier, the sine is the y-coordinate of the point of intersection of the terminal side of the angle and the unit circle. So it's this y-coordinate here. That is, this is equal to the square root of 3 divided by 2. All right, let's look at another example. Let's find the exact value of cosine of negative 7 pi over 4. Now the cosine of theta is the x-coordinate of the point of intersection of the terminal side of the angle and the unit circle. Which means we need to find the point where the terminal side of this angle here, negative 7 pi over 4, intersects the unit circle. That is, we need to find this point here. And since negative 7 pi over 4 is here in quadrant 1, its reference angle here is 2 pi minus 7 pi over 4, which is pi over 4, or 45 degrees. And so we can draw this triangle shown. It is a 45, 45, 90 triangle with hypotenuse equal to 1. And therefore, the lengths of the other two sides are both square root of 2 over 2. Again, let's think about why this is true. If you recall from geometry, when you have a 45, 45, 90 triangle, it forms an isosceles triangle. So let's call this Z and this Z. Both of these lengths are equal. And by the Pythagorean theorem, we get Z squared plus Z squared is equal to 1, or 2Z squared is equal to 1, which means Z squared is equal to 1/2, or Z is equal to plus or minus the square root of 1/2, which is equal to plus or minus the square root of 2 over 2 if we rationalize the denominator. But since Z represents these two lengths here, then we're going to choose the positive value here. That is, Z here is square root of 2 over 2. Same here, this is square root of 2 over 2. Which is how we get that triangle there. All right, so therefore this point here is square root of 2 over 2, square root of 2 over 2. And like we said earlier, remember that the cosine of theta is the x-coordinate, the point of intersection of the terminal side of the angle and the unit circle. And that's this point here, so the x-coordinate is here, which would be our answer. This is equal to square root of 2 over 2. Now, angles whose radian measure are multiples of either pi over 6 or pi over 4, like these two examples here, are called common trigonometric angles. This first circle here shows the multiples of pi over 6. This is 1 times pi over 6. This is 2 times pi over 6, or pi over 3. This is 3 times pi over 6, or pi over 2. And then look, 4 pi divided by 6, or 2 pi over 3, was our first example. And remember, we found this point. And then this second circle here shows us the multiples of pi over 4. And remember, the angle we saw in our last example was negative 7 pi over 4, which is coterminal with pi over 4. And we found this point here. Now, rather than having to derive the x and y coordinates of these points each time, like we did in our examples, you're going to want to memorize these circles. And really, if we just memorized these 1, 2, 3 points, then because of the symmetry of the unit circle, it's easy to find the other ones by affixing the appropriate sign in front of the numbers. For example, here, we know that this point that corresponds to pi over 6 is square root of 3 over 2 1/2. by the symmetry of the unit circle, then this angle here, 5 pi over 6, also has these same values, square root of 3 over 2, 1/2, but we put a negative on the x-coordinate because x is negative in quadrant 2. So it will be to your benefit to memorize these circles. All right, and this is how we find common trigonometric values. Thank you, and we'll see you next time.